Welcome to Dev Days of Summer 2024. This is Program the Rainbow, working with colors in Delphi. The slides are down there at the bottom on that GitHub repository, although it links to a different repository that has the samples in it. My name is Jim McKeeth. I am the Director of Consulting for GDK Software USA. And if it looks like I'm moving right now, that's because I didn't get my treadmill time in and it's late, so I'm going to do treadmill while I'm recording this session. Because I don't know about you, but if you've ever thought you knew something really well, but then you go to put together a session and discover there's a lot of little things you didn't quite have figured out, that's what happened with me on this one. And I learned a lot. Hopefully you will too. So, always program to an interface and always present to an agenda. This is basics what we're going to cover. Oh, I didn't get to color names. Oh well. In the sample repository, you'll find lots of color names. So color theory. This was started back in 322 BCE with Aristotle's musings on color, but then it really was formalized with Isaac Newton's optics. Now, if you remember, Isaac Newton famously showed that you can split white light into the visible spectrum using a prism. And he started coming up with the idea of complementary colors, or the primary colors and complementary colors and stuff like that were all came from his optics. So we have the color wheel is a representation of the visible spectrum with the colors going around 360 degrees. And typically, actually every time I've seen it, 0 is red, and since it goes around as a circle, 360 is also red. So we've had different primary colors throughout the years, but the primary ones we use today are red, green, blue, and CMY. Red, green, blue are the additive primary colors. They are where you are starting from darkness, black, and you add more colors to that. And if you add all the colors, you eventually get white. CMY is the subtractive primary colors, where you are starting on white and you're adding color onto it, subtracting away until you get to black. So CMY is what you use for pigments when you're printing on white. RGB is what you use for lights when you are displaying something. Color science is really the evolution of the modern evolution of color theory, and they kind of overlap a little bit, but so some of the stuff we're talking about is color science, some of the stuff is going to be color theory. But there's some good Wikipedia articles down there you can check out. So one thing about colors is you have to understand the way the human eye sees colors, the way our vision perception works. Now we're going to not get into the fact that some people are colorblind, but the different colors are more, our eyes are just more sensitive to different wavelengths of colors. And interestingly, we use red, at least here in the US, for fire engines and stop signs because they're supposed to get your attention. But green is the color that is most visible to us. So, and then down at the bottom there is showing the spectrum, and it's interesting because we have the most wavelength of colors dedicated to red, followed by green, and then violet, with very small amount dedicated to what we'd call orange or yellow or blue. Now the red goes beyond that into infrared, and violet goes beyond that into ultraviolet. All right, enough color theory, although we're still going to touch on some of that as we go. Let's look at some code. For the longest time, Delphi had the TColor, but then with FireMonkey we got the AlphaColor, which adds more features because it has an alpha channel built into the color, but they're incompatible. If you look at the declaration, they're both in system.ui types, you'll see that TColor is a integer subrange, has both positive and negative values, whereas alpha channel is a cardinal. So it has the full range of a cardinal, but it is positive only because it's a cardinal. Now, the compiler will let you just use these. You can assign one to the other and it doesn't care. Now, So what that does mean is that you can run into range check errors if you're going from a alpha color to a color, because you might have a value that doesn't fit, or vice versa. Now, where it also gets you into trouble is if you look down at the bottom there, the variant record, you see that the TColor goes RGBA, okay? But the TAlphaColor goes BGRA. So the bytes are in different orders. They're backwards. And so even if you do like remove the alpha and move it across, it still won't work. Now there are some routines that are supposed to change it, but I didn't see, it seemed like they didn't work right to me. I filed an issue in Quality Portal. You can go check it out there. It has some example code. So yeah, be very careful working with TColor and AlphaColor. Even if a parameter or a function will take an alpha color and you pass a color or vice versa, it will pass it and it will compile, but then some colors, depending on what you're doing, either give you error messages or just the wrong colors. CMYK. We talked about CMY being the subtractive primary colors. K is black or key. This is the color palette you use for, not palette, the color definition you use to print when you're putting on pigments. There's an example there of 3 colors, not showing the black there, but this is what you use for physical representations. By its nature, it doesn't fit on your screen. Your screen is light, whereas this is pigment. So there are conversions, which I'll show you some, but unless you have a color space or color profile, which by the way, Skia has support for color spaces in it, you're approximating. Even then you're approximating it, but with a color space or color profile, you can do things like understand the way the screen is displaying things and adjust better for that. And you'll see this a lot in printers and in like graphics programs. So here is some code that will convert RGB to CMYK. If you have black, if it's black RGB, you need to do that manually, where you just set K to 1 and the other one's to 0. But otherwise, you can just, here's the math you do. You take 1 minus red divided by 255. So you're taking red has a value from 1 or 0 to 255, and you're converting that to a floating point value. You take the minimum, whichever one's the least, and that becomes your K, your black. And then you do some math adjusting black out to get the inverse, to get the complement, because CMY is the complement of RGB. And then going from CMYK to RGB is much easier. You're just taking the inverse. You don't have to calculate the key, the black. HSL. This is the more useful way to define colors than RGB or CMYK. CMYK and RGB are great for defining a color, but for working with colors, HSL is where you want to be. And sometimes I call it luminance instead of lightness, but it's technically lightness. I'm not sure where I got that from. But anyway, H is hue, S is saturation, L is lightness. So hue is a value from 0 to 360. Now in Delphi, it's from 0 to 1. So you have to take, if you want to work with it as an angle, 0 to 360, you have to take that and divide it by 360 or multiply the single by 360 to get an angle. But that's what it's showing you, that's what it's representing, is a value from 0 to 360. And that's where you do the interesting things, which I'll show you in a minute. The S is saturation, that's the amount of color. A 1 or 100% is a pure color, whereas 0 would be gray. And then L is lightness. 0.5, 50% means it's a pure color, whereas if you go greater than that or less than that, you go lighter to white or darker to black. So there are some routines built into Delphi in the UI const library unit, HSL to RGB and RGB to HSL, as well as change HSL, which is really useful. It lets you provide a alpha color and then a delta for how you want to change the hue, saturation, or lightness. So if you, it's a delta lets you change those. So it just gives you back an alpha color when you're done. So making a rainbow. This one was one that I thought I had the answer to, and then I dove down this rabbit hole and found out it's a lot more interesting than I thought. And this goes back to the way we see colors. Okay, so Newton, originally I had a rainbow definition that had fewer colors than this in it, but when I was a kid, I learned Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. That's the mnemonic for memorizing that. That was Newton's definition of the rainbow, was red, orange, yellow, and you can see there's the hex representation of that. Now, if you look at this, you'll see that it's kind of skewed a little bit. It doesn't feel like it's going through the colors smoothly. So the modern definition of a rainbow, as far as drawing a rainbow, is there in the middle: red, orange, yellow, green, cyan, blue, magenta. So it has, it's the two sets of primary colors, red, green, blue, and yellow, cyan, magenta, combined with orange added. It's interesting they added orange, but otherwise it would just be the two sets of primary colors. Now, if you just want to do it by hue, which is the way I had done it originally, until I went down this rabbit hole and discovered there were other definitions for it, then you take, the one there, where we have red, yellow, green, cyan, blue, magenta. And that's just the two sets of complementary colors combined together. And you can see there is the hue, right? So we start hue 0, which is red, and then go 60 degrees, 60 degrees, 60 degrees. And technically, if you're doing like a circle or a full gradient, it would have a seventh point at the end that would be 360, which would be back to red. Now, so it depends on if you're doing a rainbow, because the rainbow doesn't wrap around, but or doing a full gradient. So I made a gradient colors picker with the Skia gradient, which I really like this one, and I also added a palette picker to it as well, which I'll show you here in a second. But the way I set it up is that it can alter so that the saturation decreases as you go to the middle. So see how it gets grayer in the middle, or you can have it so that it gets lighter in the middle, so the lightness goes up, or lightness goes down, it gets darker in the middle. All right, so here's the palette picker I showed you. That's a screenshot from that as well. Once you get into HSL, palettes and complementary colors is a piece of cake. It's just a hue alteration. So you leave the saturation and luminance the same for a color. You take whatever color you want. You just look at the hue and you do a delta on the hue if you want to get the complementary color of 180. And that goes across the circle and gives you the complementary color. If you want to generate palettes, like a split complementary color palette or whatever, there they are. So 0 degrees is the starting color, and then the other ones are the other colors you're generating based off that starting color. And there's more you can go into if you go down to the Wikipedia page, color scheme. You can read all about some of the other ways to do that too. And lastly, we're going to talk about shades, tints, and tones, which I had known I built a demo for this, but I couldn't find it, so I rebuilt another one. And it was, I don't know if it was my eyes or what, but it didn't look like it was right, and I messed with it a lot, but it appears to be right by math. So tints, shades, and tones are three different things. A tint is when you take a pure color and you add white, so you're lightening it. You're increasing the lightness. So 0.5 is a pure color with a lightness of 0.5, and then as you increase that towards 1, you're tinting it, eventually till you get to white. A shade is the opposite. So a shade, you take a pure color, you start with a lightness of 0.5 being a pure color, and then you decrease that lightness to 0, and you're shading it, you're moving it towards black. And then a tone is moving it towards gray. Now this diagram shows it as the combination of the shade and the tint, which would work, but with HSL, all you have to do is decrease the saturation. So you take the saturation, actually it should be the other way around, 1 to 0. So 1 would be the pure color, a saturation of 1 is a pure color, and 0 would be gray. Here's my gradient editor that I used for those gradient screenshots you saw. So this is the hue-based one, and this one does wrap around to red again, so it has 0, well, it's not showing it in degrees here, but this is percent of placement along here, and the RGB values. So you see it's all Fs, just moving the Fs across. And I did this one because I wanted to experiment, because I wanted to figure out how many points I needed. Because if you just have, let's see, a few points, right? And so I say I want to start at red and end at red, right? Then it's just red if I just have 2 points. So it's like, how many points do I need? And I was messing with this a little bit, thinking about it. I was like, oh, that's right, Roy G. Biv. And so Roy G. Biv is 7. And so I tried 7 and that worked. And then I just saw that if I add another one, it actually doesn't look as good here. I don't think. It's got 2 greens that look identical to themselves there. And then as I add more, it doesn't actually get better than 7, right? So if I go to 14, which is twice as many, or 15, it doesn't look a lot better than 7. So, I can make this bigger here. 7 seems to be the right number to go with. I did add in the Newton, so this is the Newton one, and this definition, you know, he didn't write down the RGB values of what he saw, but this is the closest we can get based on the way he described it. And then this is the modern definition of the rainbow, which has the orange added in there. So there you go. That's kind of cool. This is a gradient editor up here that you can use. It's a component in Delphi. And you can edit use a color picker here, so you can change these colors of each individual gradient colors. Oh, and then I was also looking at the difference between radial and linear gradients. So this is simple sliders. This is just a simple thing here to show the way you can define colors with either HSL. So this here's the hue. Here is your saturation. So as I turn it down, you see it's getting grayer. And the luminance right now is in the middle. So we got a nice blue. And if I go this way, we get darker till we get to black. And then go this way, we get lighter till we get to white. This is showing the actual values. So even though, like I said, that you want to think about this as 0 to 360, the values you pass to the HSL to RGB are 0 to 1. So there's 0 is red and 1 is red again. And then down here, this is RGB. So increase red, increase green. So we go all the way up on both of that, we get yellow. If I bring the red back down, and then go, so we have green, and then bring all the way up here, we have cyan. This is the main thing I wanted to build with this. And so this is actually, these are custom components I built here as well, that you can install them here with the color editors. And so this one, as you change one, it changes all of them. Although there's some oddities here, I'll show you. It's easier to show on this one with the hue, is as I'm going here. So when I get all the way to the end, it's like, oh, red, that's red back here. So the hue, the red wraps around. Although I guess if I make this, maybe instead of being 360, if I make it 359, right? If I don't go all the way to 360, then maybe I'm fine. So that's what I got to do, is not let you go all the way to 360 for it. See, I guess there should be 0 to 359, and not 0 to 360. So that makes sense. But then also, if you go on your luminance, if I take the luminance down to black, then it loses my hue because everything gets converted into RGB behind the scenes. And I find out that's a bad idea because RGB, when you go to black, it's just black. There is no hue. So I need to keep track of the hue and saturation separately. Why can't I? Well, that's interesting. Huh. All right, so like I said, still got some work to do. But I love watching the RGB sliders move as I do this. That's just so cool. And then here's CMYK. So you can convert here. Now this is just going to be an approximation because CMYK isn't designed for going on screen. CMYK is for putting on pigments. But there you go. Up here is a palette generation. So this is the complementary color of whatever color I select over here. So we'll get a nice purple, and we get green as the complementary color. If we go for a pure blue, you see there's yellow as the complementary color. And then here it's generating some of the different types of palettes. There's probably some more I could put in here as well, but it takes the primary color here, the base color, and then generates a quad, which is a 4-color palette. Analogous. I can't talk right now because I'm on a treadmill. Anyway, so there it goes. You see the palette generation. And then here's just a color picker so you can pick from some of the stock colors as well. Oh, and it has alpha down here at the bottom, so you can adjust the alpha on all of them too. So this is the color picker, which I added a palette to as well. So right now it's just doing a triad palette, I think is the one I'm doing, but the code I could expand it out to do different palettes. So the gradient, you can change it. You say I want to have it go to lightness in the middle, or I want to have it go darker in the middle, or none. And then as you move this around, it's giving you the color that you selected under the mouse. And it's not displaying, I guess it should display the hex for those colors there, but it's not. Something to do. It's in the code. It's in the code, so you could easily get it there. And this will save the screenshot for you, so you can include it in your slideshow. Let's see. I'll show you the. Oh, I was going to show. If you go into the system.skia, you'll find there is the TColor space and profiles. So these are the things I talked about before, where you can use profiles for when you're converting between RGB and CMYK to get a more accurate color representation. Okay, so this is the, oh, I didn't show this one. This is the tint, tone, shade, tint, and tone. So you can define how many variations you want here, and then it will generate those for you. This down here at the bottom just showing you the different values, whether it be the lightness, saturation, or lightness going in the other direction, right? So we see this one goes from 1 to 0.5, whereas this one goes from 0 to 1. Or wait, yeah, this one. This one goes from 0 to 0.5. So this is the tone here in the middle. They're in the wrong order. And this is the preview of the pure color here. All right, so let me show you the code for this one here. It's all in the paint on the SK paint box. So I'm just doing an HSL to RGB. It's a loop, and on this one, because it's tone, I change the saturation based on our position in the loop. So it's just a percentage there. Whereas the tint and tone, I do it either This one is 1 minus that times 0.5, where this one's just S minus, or S divided by sample count divided by 0.5 to get the shade. Okay. Here is the shader, the Skia gradient view, which does the palettes. And probably a better way to do this, but this is the way I came up with doing it, is I actually have 2 paint boxes. Okay, so this paint box here is the base paint box, and in here I am drawing the gradient, the color wheel. And right here is where I look at the radio buttons to determine which radio button you selected. And I probably should put that outside there. Could be refactored. And then right here, I'm making a gradient. Let's see, where's it at? Right here. Make gradient sweep. So I call this method in the SK shader, and I give it a destination center point, and then right here is a routine I have that creates a gradient array. And this is just using the hue-based one. And I did it in decimals instead of, I guess I could have done it in hues. HSL to RGB. Yeah, if I'd done like the 0 and then 60 divided by 360, 120 divided by 360, that would have worked better. It would have been more readable, I think. So then the mouse move, oops, let me find the right one, is I have this routine called move circle, and it looks to see if the circle's inside, or if the mouse movement is inside the circle, so instead of the whole rectangle, if it's actually in the circle inside the rectangle. Then it moves, it has I actually have a little T circle that it moves to the point that you selected, and then I get color, right here, get color gets the color of the color wheel. Now, I do this in 2 steps because I get the color from a bitmap that I cache every time I cause the color wheel to redraw. So that way I don't have to screenshot it every time if I haven't changed the color wheel. So if the only thing that's changed is the circle position, then I don't re-screenshot it. And all I do is map the bitmap to get the pixel at the location. But then the palette is actually done in a separate paint box. And so here, I get the location, and then I call this draw circle, which draw circle does the interesting math right here, get rotated point. So get rotated point, I pass it the origin, which is the mouse, the mouse point, the original circle, the center of the circle, and then the radius. And then theta is how many degrees I'm moving to. So remember when I showed you the different degrees you move to for the different palette types? That's the theta. And so we get the distance from the center, arctangent, and then you draw at the angle. Your good old calculus here. Calculus, trigonometry. That's what it is. And there we go, get the values there for the new one. There we go, this is the color slider. So these right now is it's a new component I made called a gradient track spin. So it has the a gradient track bar, which is a new component I made as well, along with combined with a spin edit and then a label. And so you can change all of that from the properties here. So here's the text of the label. You can set the what do I call it? Begin color? Yeah, color end, color begin right here. So I can change those. that back. And I'm also I plan to roll this all up into a single component, so you can just drop down a single component on your form to give you this RGB picker. And then the palette code, oh, here it is right here, get palettes. So I have a routine here in another library that is the color palettes. And so it's a record that you can call either, you can use the record, it's a record that holds a palette, and you can use it either via the record, so you can create it and say what kind of palette type you want, or you can use one of these functions and it returns a color palette for you. And so the color palette just contains that color in it, or the palette that you've asked for. And so that's what's displayed here. And the source code for the color editors are in here. We have the more track bars is just a gradient track bar. Originally I was going to add some other track bars, but I didn't end up needing to add those. That's right. Hue track bar, alpha track bar. I thought those needed to be added, but they're actually already in there. They must be fairly new because I don't recall them being in there before. Then the track and spin is all three combined. And I did actually implement the interfaces on it so that it can support like virtual keyboard controls and text actions and stuff like that as well. Seemed like the right thing to do. And then here's the palettes, which I just showed you the code for that. Oh, and then I have the CMYK util here. This is based on some code I found online, but I've changed it quite a bit, but I still have the credits in there. I'm planning to rework this a lot, actually. I want to make a robust color record that has the ability to store both CMYK, or all three CMYK, HSL, and RGB, and then not lose resolution when you change it around. Not lose like the hue, for example, if you drop the luminance all the way down. And it has support for HSL and RGB to CMYK. Actually, I don't have a CMYK to HSL. That seems like I guess I should add that. And there you go. Yeah, so you can download the code and play with it and have fun. If you notice anything, do let me know. All right, we've made it. It means I've got some good walking time in here. Resources. Here's the slides, Programming in the Rainbow on GitHub. And then this is the samples I showed are all in here. And this has got a lot of other stuff in here. It's something I've been working on for a while and still have a lot more work to do on it, but there's a lot of great useful code in there you can go grab. It does say FMX color dialog, but it's not all FireMonkey specific. The libraries like CMYK and palettes and stuff like that are not FireMonkey specific. They'll work with any alpha color, but the main chunk of the library is FireMonkey. And with that, we're done. So it's time for Q&A. And I probably will not be on the treadmill for Q&A.
Jim is such a great developer, he really is, and also completely staring crazy. Here I am on my treadmill. we were chatting behind the scenes, saying that we should start a trend now, don't you think? I'll just make sure you're not muted, because I
think I'm unmuted.
No, you're unmuted. That's good. I think we should start a trend. And I said, we should do one, because that's the first time I think anybody has ever presented. I've never seen a presenter before presenting with a treadmill. The only person actually I've seen do something similar was Linus Torvald from Linux. And he was they did a behind the scenes with a Linux kernel developer, and Linus was one of them for obvious reasons.
Mhm.
And he was talking about how he uses a treadmill on a walking desk. You know, like he codes whilst he walks. I don't know whether you do that as well, but he may be the only other person I've actually seen talk and use a treadmill at the same time. So, well done, you're a hero. You really are an absolute hero. I don't know what to say really. And you know what? Someone, where was it? I got this one. This person, I don't know if it's a woman or a man actually, but blank on FA said, "Is Jim exercising?" Yes, he is. And also a lot of love for the name of your project as well. Jim's over-engineered color picker. Well, you know, I mean, it definitely is amazing. You know, so, and lots of people saying, "Great, you know, good job on what you've done," and all the rest of it. And you put your slide link up here. I'm also going to put the QR code up there because I've learned to point to it now. Look, I'm all grown up and everything.
Yeah.
And that's where you can go. That's the link to the repo for the program in the rainbow. But if you go down one level in and up, you'll see the other example as well. Jim, that was a hell of a presentation. I have to say, I actually saw you. I think was it in Amsterdam you were working on that? I forget. I saw you working on it somewhere, and you were talking about it. And
it might have been. I've been working on it for a while, and there's actually some other pieces in that project that aren't that I didn't show, but
yeah, it may have been actually when you came to Dallas as well, because maybe even you were doing it then. Because I remember you showing me some stuff, and you're like, "Oh, I'm working on this," and I'm like, "Oh, that's a really cool project," you know. Very good demo as well. It's quite, the dog's gone, by the way, so normality has returned. You're static, and I'm not carrying a dog around whilst I do hosting, which is the normal range of things.
It was interesting working on, because it's one of those things that colors are one of the things that I thought I understood, but then when I started working on it and poking into it and doing stuff with it, it's like, oh, well, that's interesting. There's little nuances about the way things work. Like, for example, the example I was showing where if you convert with HSL, if you turn the saturation or the lightness too far to the gray or black or white, then you lose your hue if you convert to RGB, which makes sense when you think about it, but it's just not something that you think about until you do it.
Yeah. I mean, I had to do a project once years ago, and it was for dentistry. I've written a lot of dentistry software. I don't know why, just that's the way it worked out. And we had one where, you know, I don't want to diss the dentistry industry, but they're quite expensive, even in the UK. There's no National Health Service in the UK, so you pay for dentistry in the UK. I think you can get like basic things done for free, but so dentists usually have like a treatment plan. So if you've got some teeth that need replacing, they will tell you we need to do this bit, then you go away and that has to heal or whatever, and they come back and then they do that bit. And so they have a little treatment plan. And the software I worked on was a visual treatment plan. It would have like waypoints where there was a little, you know, pound symbol, because it was in the UK, a pound symbol where they had to pay, and it would draw circles and connections and things. And I had to write a color handling unit for that, because they wanted to be able to pick, you know, colors for the circles and the connecting lines. And it's harder than it looks, you know, because let's like say, oh, we want to be able to create a theme automatically, like a color scheme automatically. And I think the reason it came up was they said, we want them to be able to load their logo in, because it's practice management software. So they'd load the dentistry logo in. I then had to examine what was the predominant color in the image, and then produce complementary colors from that, like you were showing in your demo. And it's hard. It is not at all easy. You think you know colors until you start looking at it and go, oh, actually, it's a lot more complicated than I thought. Yeah.
Well, and that the way that TAlphaColor and TColor works
was I knew they were different, but because of the fact that you could call a method and pass one or the other interchangeably, and then you'd get different results because the data internally was different, and then range check errors and stuff like that. That was throwing me off quite a bit as well. It's one of those things that I knew that they were different, but then when you could pass them arbitrarily and the compiler would accept it, that I didn't realize what I was doing wrong, and then I was getting these weird errors. But I have another video I wanted to show. I used Camtasia to edit this one, and for some reason, Camtasia just choked on this video clip. So it's uploaded on the back end there if you can play it. It's just like 1.5 minutes long.
Oh, let me have a look. Oh, of course, I can't see it. Martha, are you in the background? I hope she is. Martha. Producer Martha.
She said it was in the video clips as well.
Well, because the way we logged on, unfortunately, I can't see it.
Oh.
So I can do it if I log out and log back in again, I think. Yeah. Okay.
Can you? If I'm
going to ping her on something else because I suspect she's doing.
There's a YouTube link if you can share that.
I think I might be able to. Yeah.
I don't know if you can share that on the screen.
Actually, you can. I can do it from here. I think you can say. Oh no, it won't let me do that either. Here we go. It's just refreshed when I tried to do it. There you go. So now I can do it. Let me just. Why is it not doing it? Here we go. Right, let's play it then, shall we?
I saw this demonstration and I wanted to reproduce it because I think it perfectly illustrates the relationship between your additive and subtractive primary colors. Now, right here I have a red flashlight, a green flashlight, and a blue flashlight, which are your RGB or additive primary colors. Now, combined, you see it creates white light. Now, if I take this pen and block it out so it makes a shadow, you'll see the shadow, there's 3 shadows. There is yellow, magenta, and cyan, which are your subtractive primary colors. Subtractive primary colors, when combined, create black. So the shadow of the additive primary colors is the subtractive primary colors. And if I do this here with the slit here, so it decomposes it back into the red, green, blue lights, and then take the shadow and cast just one shadow over that, we'll see that when I cast the yellow shadow over the slit, it blocks blue, which is the complementary color of yellow. If I block the magenta shadow over it, then it blocks green, complementary color, and the cyan shadow blocks red, which is its complementary color. And it just looks cool too.
I love it. That's great. Let me just make you come back into the screen. There you go. Yeah, that's beautiful video, Jim. I really like that. That's kind of one of those ooh moments, I think.
Yeah. I watched it on YouTube, and actually the colors are muted on there too. So if you watch I put the link in the chat for the directly to the video. If people want to go grab the video directly, it looks a little better.
Oh, okay. I can. You can. You able to post that? Let me do it just in case it won't work, because sometimes it can be fussy about the links. Some platforms edit them out. So I'm going to do that, and it should allow my link through. So there you go.
Okay.
Yeah, really good. You know, you are a real master at these presentations like this, but doing it whilst you're exercising it as well, I just blown my mind. I just can't believe that. You know, it's And people, I think people know you, but we'll just to make sure that we keep Mark OG happy, because he's an awesome guy, but he is your boss effectively, and so is Keith. But you actually work for GDK Software. You are the director of the US GDK Software, is that right? Yeah.
Correct,
So
yeah.
you're director of US GDK Software. Really, I haven't got enough good things I can say about GDK. Really, they really nail themselves to the mast of Delphi. Really, and I respect that. Dion's company is the same. They're all Delphi through and through, and quite a lot of people are champions of it. But GDK really do carry the flag when it comes to that. So I've got a lot of respect for them. There's plenty of others out there as well that are similar, but GDK just recently are on fire. And of course they are, because now they hired you. So you are marching around. You've been on a bit of a tour recently, didn't you? Go to Orange County.
Yeah, I was just down in Orange County, and did a set. You were on they had people in person and then a live stream online, and looking for some other additional stops as well. So just kind of touring around the U.S., but looking just to raise awareness in the U.S. to see if there's customers or people that need some Delphi consulting in the U.S. or Canada. So if that's anybody out there.
Well, let's briefly talk about what GDK do, actually, because that we keep saying about GDK and talking about the Delphi Summit, which was incredible. But how would you characterize GDK? If I was to, as I said earlier on to someone else in the elevator pitch, so you're on the bottom floor, you got to the 21st floor. What's your elevator pitch for GDK Software?
Well, so it's a group of it's a Delphi consulting company, basically. But the one thing I see different from some other Delphi consulting companies is that we are all about Delphi, and that we have a lot of things in place. We have a great team with a lot of continuing education programs for the team to make them better developers. And that means that we're really good at what we do because everybody there is very knowledgeable and very enthusiastic about working with Delphi. So,
yeah, I mean, if people didn't see your other session, you were talking about the company culture, where it's all about education and going for walks together, which is very un-American, I have to say, but it's quite British, because Brits do it, but they usually walk together to the pub, which is not quite the same principle, but
yeah.
It's and I mean, there was back in the days. I think Silicon Valley has lost its shine a lot. Actually, I think maybe 10 years ago, Silicon Valley was definitely, everybody wanted to work in Silicon Valley if they were young and a developer. But I think it lost its shine. I think people like Elon Musk came along and questioned why there were free bagels and massage therapists sitting at your desk and things like that, which kind of had gone too far, I think, a little bit. I think it's fair to say that without being too horrible about Silicon Valley. And I'm just jealous because I never had any of that. I worked remotely for 14 years, so I don't get any of that. But I do get bagels brought to me and things. But I think that what you were saying about the culture of GDK actually combines the best parts of that, which is valuing the individual, but the principle being you're part of a group, and that you all fail together or you succeed together by making the individuals club together and raising them up to make a better whole than just the individual parts. And that's something really to admire, I think, because it's not common in many software houses. I have to say, I've worked in probably 10 software houses off and on, and some of them were like that. Some were great. You would have a company kitchen and people would do team building days and things like that. And some of them were absolutely, why are you talking to that person? That's you're coding. And of course, those places, surprise, surprise, were horrible places to work and didn't keep their staff very long, and actually produced a very negative culture that produces bad software. Because I believe that software development is a creative industry as well as a science. I think that if you want creatives to be creative, GDK are probably going about it the right way, which is nurturing that inner human so that they feel like they're valued and their mental and physical health is plus. And as much as I joked around about you working out, I respect you for that, because anybody that's met me in person knows I'm quite a big guy. I'm quite big. I mean, you're tall as well, but I'm big, around the waist, and that's because I don't work out. So it's one of those things, isn't it?
Well, that's one of the things about GK is because, like you said, they do invest in the employees, which is something I really respect, because I've seen a lot of companies that see employees as interchangeable, and that's kind of the trend, like you said, in Silicon Valley. Things have changed, is that they're starting to see, developers as one's good as another, but the investment in the staff, which I value from a humanitarian point of view, also translates into attracting the best developers and keeping those developers, and then getting them integrated into a team where they work better together. And so they're deliver projects to get things done quickly, and they do a really good job. And which have a number of customers that we've done work for, and they're like, this is way cheaper and way quicker than I expected it to be. And that's the result of that, is just because we have a good team that's good at what they do. We get things done quickly.
Yeah. And also, being cost effective, because that's a better word to use than cheap. Being cost effective, it also means that you get work in the future.
Yes.
Because there's two mindsets, isn't there, to pricing. You can either charge a massive amount of money and then you get one job every 5 years, or you charge a reasonable amount of money and you're always working. And eventually that translates into a better income overall, because it's being efficient at what you do means you're also able to charge a price that is not as perhaps high as someone who is not very efficient. So yeah, good stuff. Okay, well, have we got that's your last session, is it, or we've got another one from you? I think that's your last one.
I think this last one I've scheduled. I don't know if there's still stuff going on next week. Or there is stuff going on next week, so I don't know.
Oh yeah. Oh god, yeah. Yeah, I'm not out of the woods yet. I've got another Thursday, Friday, and 5 days next week, so another 7 days.
Wow.
Someone's asking, is there any chance that these videos will be done using C++ Builder? Actually, it wouldn't be that difficult to convert that code to C++ Builder, because although it's Delphi, thinking about it, it's probably relatively easy to convert to C++ Builder because of the classes it's using. But it's a good question. We do have
theory,
C++ content coming, so
it should work in C++ as well, absolutely. But
yeah.
I've done C++, but it's not my forte.
No, it's not mine either, unfortunately, for everybody else. But we do have C++ content coming, because Whole Tomato are going to be turning up doing some stuff, and Visual Assist, and I think a few others. And we had Roger Swan do a great demo yesterday as well. So yeah, it's good stuff. Okay, well, Jim, I'm going to let you go, and we're going to start talking about some other things as well. But thanks once again for your efforts. You're a great developer. We always mention this: invented swipe to unlock. His name is on the patent. I mean, I know there were other people involved, but Jim, if people go to their phones and they swipe to unlock or they draw a pattern, that's the guy who points at. Wait, does it do it that way? There you go. That's the guy that's responsible for that. So if you hate it, blame him, and if you love it, praise him. So
I didn't put it on the iPhone, but yes, I had the patent for the technology.
I'm sure Steve Jobs claimed he invented it anyway, because you know how he did things. But also, you're a good friend. We get on quite well outside of work. We'll talk about development and lives in general, and we met up a few times. And
yeah.
Anybody who's watched us sword fighting and a few other things know we've got a similar sense of humor. And even though Jim did try and electrocute me with a Tesla coil at one point, but I'm sure he didn't mean it. Yeah, exactly. All right. Well, thanks a lot, Jim.
Yep, absolutely.